Hi, I am doing a video on the practice exam solutions for Math 158. Let's start with question 1. You start a savings account with $1,000. It sounds like $1,000 would be your principal. So I'm going to write principal equals $1,000. This account earns 0.45% per month. Okay, there's a couple things strange about this. One thing that's strange is usually you're given the APR or the annual percentage rate, but not this time. Look how we were given the monthly interest rate. That's already equal to what we call R, or again, our period interest rate. So normally we have to do some division to get R. Normally we do APR divided by the number of periods in a year. But this time, periods in year. This time, they're just giving us what R is, so we don't have to do any dividing. Look how it says this is our interest rate per month. So it is already our period interest rate. So it's equal to 0.45%, which the other thing that's weird about this is that this looks like a decimal already, not a percent, because it begins with 0.45. But it's not. The percent sign's there, so it is indeed a percent. So to turn it into a decimal, we have to move the decimal place to the left 2 times, or divide by 100. 0.0045 is going to be our R. When will this account reach $1,124? Look at this. This is giving us our future value, or our balance. So I'm going to write future value equals, let's see, 1124. Round to the nearest month. Hint, 0.45% is not APR. We just talked about that. It is our monthly interest rate. Also, what is 0.45% as a decimal? We talked about that. It is 0.0045. Okay, so this is talking about a savings account that is compounded monthly. What we need is our 4.1 savings account formulas, and in particular, we need the one that is talking about compound interest. Actually, this one talks about compound interest too, but notice this one wants the APY, which we were not given. This one wants the R, which we were given. So we're going to use this one. So we have the future value, in other words, the balance after T periods. So 1124 goes in for the left part. That's supposed to equal our principal times 1 plus R to the T power. What is T? It doesn't look like I wrote anything about T here. And in fact, look what the question is asking. When? When will this account reach 1,124? We're supposed to solve for T. All right, well, we could do that. First thing first, I'm noticing 1 plus 0.0045 is just 1.0045. So let me write that down. And that's to the T power. There's a 1,000 here. And there's 1,124 on the left side of the equal sign. All right, what I want to try to do to find when the account will reach $1,124 is I want to solve for t. I want to isolate t, and therefore I need to get rid of this 1,000 and I need to get rid of this 1.0045 as well. The easier one to get rid of, I think, is the 1,000 because it's being multiplied. All I need to do is undo multiplication with division. So I'm going to write divide by 1,000, divide by 1,000. And I get 1.124 equals, when I divide the right side by 1,000, 1,000 goes away, that was the point. So on the right side I get 1.0045 to the t power. Now, I want to isolate t, so I want to get rid of this 1.0045. I can't subtract the 1.0045 away because these two quantities are not being added together. It's not 1.0045 plus t. I can't divide it away because these two quantities are not being multiplied together. It's not 1.0045 times t. It's almost as if we're stuck. The 1.0045 seems stuck to the t. Our only hope will be to remember this property of logarithms that says if you have, let's see, how did it go? If you have something like log of blob to an exponent, you are allowed to bring the exponent out in front. So you would get that to equal t log blob. Look, the exponent's not up there anymore, it's in front. Now you have this multiplication problem instead. If there was a log here, we would be able to use that trick, but there's not a log there. But this is an equation. We could do whatever we want as long as we do the same thing to both sides. So we will log both sides. And now that t is allowed to come out in front just like we saw right there. And so we get log 1.124 equals t log 1.0045. And you can't see it, but this is really t times. So I'm going to put the times there. Log 1.0045. Now we can think, hey, how do we undo multiplication? We undo multiplication with division. So I'm going to divide both sides by that log 1.0045. Divide by log 1.0045. On the right side, it just goes away, and we're left only with t. There, now we can see all of it. On the left side, we have log of this divided by log of that. I'm going to write it nicer. I don't know. I'm running out of room. I guess I'll write it nicer. Oh, down this way. T equals, that's all that's left on the right, log 1.124 divided by log 1.0045. Now, it is okay if you don't remember what logs are because your calculator remembers. So here is my calculator, and I am going to type log 1.124, and I'm going to close those parentheses that formed, and then I'm going to type divide, and then I'm going to type log 1.0045, and then I'm going to type equals, and I get T equals about 26 point, I don't know, 03-ish? What are we supposed to round to? Round to the nearest month. T is approximately 26. And look, because we are compounding monthly, T is the number of months. So I'm going to just say 26 months. And there we have it.